Alright, hello everyone, it's October 3rd. I just finished working today. Maybe I worked too much today, but yeah, it's alright. Things like this happen. It happens. Is this the same as what we did yesterday? Heights and vertical lines. Draw such that the two endpoints of the ith line are I0 and I height. Oh. Find two lines that together with the x-axis form a container such that the container contains the most water, but to the maximum amount of water a container can store. The above vertical lines are represented by the array of this. In this case, the maximum area will be blue section, which can contain this. So the amount of water is determined by the smaller of the two, right? So what we can do is starting from, because at the end of the day you will have to pick something, right? You have to pick something as one of the sides, and then you have to find another as the other side. So if you pick something, then you need to find, and I consider this as the smallest, right? If we go left to right, I consider the left one is the smallest, and I need to find on the right the smallest, the biggest, the smallest that's bigger than me. Right, and that's, so what we can do, I feel like this is a monotonic array that every time when you come in, what you want to find out is the small, so if we do and a monotonic increasing, right? If it's a monotonic increasing, so when you have a small come in and I say, okay, I'll think of this small one as the lowest. So we look to the left, right? I'll look to the left, but shouldn't you look to the left and look to the right? We should look to the left and then look to the right, but we'll look to the left first. So monotonic increasing, so we look to the left, I will pop until I find, because it's monotonic increasing, so I find, monotonic increasing. Right, so monotonic increasing, I will pop, so these are all bigger than me. Right, so I'll pop until we find something that's smaller than me. And the last one that I popped, right, and this is the amount that I can get. I can put my water. That's actually, then the next one come, if it's bigger, and I just attach to it. That doesn't make sense. Maybe it should be monotonic decreasing. If it's monotonic decreasing, then I'll have this, and this will be kick this out. And the most that they can get is whenever you kick someone out, this towards this is what it can do, right? Okay, so decreasing, boom, this is increasing. So then if it's increasing, then you'll kick this out. Now it'll kick this out, and then so there will be amount of water that can hold by this is this much, right? Is this much. But it doesn't matter, does it? Because as you're decreasing, you know something is big, right? So as you're decreasing, so every time you're decreasing, and this will comes in. Yeah, this will come in, it will wipe out everything. basically, given this, right, I want to find the smallest height on the right that is bigger than me. No, I want to find from right to left who is the first one that's bigger than me. So in this one, this is, right? So if I put a thing here, so if it's here, then I do this. Then I go here. This is bigger. Then it's bigger, so I go from right to left. So I'm here, right? So I want to find the first, that's this, right? And I move here, which is this. I move here. Because this is bigger, right? This is bigger than this. So I move here. So this, yeah. So like starting from here, I can go both sides. But here I say, okay, I go here. And then I move. It's the same now. I handle it, doesn't matter which side. So I can move, let's say if it's same, I always move this side, so I move here. So this is smaller, so it will be this. Or here is smaller, I'll go this. This is still smaller, then we go this. Yeah, it's like this. I have to go left and right. So I need to keep the large on the left and the large on the right. But that doesn't make sense, right? So this I'm pointing here. And I'm moving here. It's actually smaller, so I don't do it. So I skip, so I go here. This, yeah, I'll go here. So basically this and this. This and this, this and this, this and this. This is skip, and this, right? So let's go left to right. Now we go right to left. So this and this. This is bigger. Trying to find the rightmost, right? Trying to find the rightmost that's bigger. And now I'm starting from here. We need to find the leftmost that's bigger than this. Doesn't make sense. Still doesn't make sense. I mean, for each one, you're looking to the left and then looking to the right, right? So what you want to know is, to the right, who is the biggest? To the left, who is the biggest? Relative to you, right? Relative to you. So on the right, so to the right, I always start from here, right? If this is bigger, if this is bigger than this, then yes, I will do that. If this is smaller, I have this one's bigger, then I basically move here, right? Because this is bigger. That's not true. That is not true. Because you can still do this one. Yeah, what I want is the most to the right. If you're smaller, then it doesn't really matter. So if it's a monotonic decreasing, then I know, right, everybody to my right is bigger than me. Right, everybody to my right is bigger than me. And if I pop something, right, that means I definitely have a higher than that. Okay, so this actually represents a bigger potential. So I have this coming in, now I'll pop it and I actually have bigger. If not, I'll just keep it. So if I have something gigantic, that is actually a cause of concern. Right, if I have something really big, I will just get rid of everybody. But that's not what we want. What are we looking at? We're looking at the smaller of the two multiplied by their distance. That's what we're looking at, right? Small of the two and multiplied by their distance. I have no clue. I don't know. 2 pointers. Oh, where to point into the move to the lower line. I was thinking about this, but how does this work? Yeah, I mean, the first one I can understand, right? And then, yes, you move the smaller. So now you get the second smallest, so yeah, you should do the same. And then you move to the bigger one. Then you do that and you move. But I can't prove that that's the best way of doing it. Yeah, it's like if we don't have, like, we have this, right? And then I move here. So this, okay, I'll say with this. Then I move here. I just say this doesn't exist, right? Then I move here. Then I say here. Then I move here. It will still say here. And that's bad because it actually should be the other side. Right? And eventually, is this as small as I move? Smaller than I move, so eventually this one will conclude as this instead of that. This is the part I don't understand. How the 2 pointer can work. I don't know. How does it work? I don't understand why this one works though. It doesn't make any sense. It's essentially the lower one I'll move. But why does it work? I don't know. Is there any way that I explain? I didn't explain. I don't know why. It doesn't. I don't know why. Why move on the smaller side? We move on the smaller side because so what you worry is if we move on the smaller side, then indeed this will keep moving until you hit here, and then we say, okay, this is. But you can think of, like, if I have something that's I used to be big, right? If I have something big, on one side, right, and then I have a bunch of different heights, then as I go through, this one doesn't change, then one of those will give me the biggest, right? That's always going to be right. Which means if I have a big one, then we move on a smaller, will always give me, okay. So, but what if I have another big one, right? As I move, boom, I hit a big one. Now, that means none of these will be handled because I'm going to move on here. I'm going to move on this side. So none of this will be handled. So will there be a scenario where, because once I hit a big one, they will always be smaller compared to this. So I don't have to compute this one anymore. So all I need to do is just move on this side, which means as you move on the smaller, right? As you move on the smaller, if you encounter a scenario where it becomes so small that you are afraid that this side is smaller than that side, you don't have to be, because this is always going to be bigger, right? You will always, as you move this way, you will always accumulate. You will always get the maximum, right? And then when you swap position, it can be guaranteed that these will be smaller. So as you move this way, it's also going to be good. Okay, this is a good explanation. I like it. But we failed to solve this one again. But at least I think this time I can put some explanation here. So when we get stuck next time, I don't know why I don't put this as a nightmare. I don't think I solved this. I never solved this one. I did remember, or I did have the intuition that the solution is should be 2 pointers, and the pointer should move in the direction of a lesser height. However, I was not able to prove it earlier, but now it is clearer. Say low is larger, say height low is larger than height high, right? As we move high to the left, we continue, we keep accumulating, right? We always keep track of the max area. So if a low never gets to move, we will have the correct solution. Now suppose a new height, this is bigger than height low. We can guarantee that all the area in height high plus 1 to this area bounded by height high 2 is smaller than the area bounded by height low to height high plus 1. In other words, we don't have to worry about the swap. Don't worry about moving from the other direction. I think this is wrong. I should try it first.